bigger, so because I'm working from the computer, it's very hard to see. And also send it to me the easiest way. I don't want zip files and stuff that are hard to download. So again, thank you so much for your great work. Actually, you're doing great. Thank you. Okay, today we are starting our last lesson in this unit and probably the last lesson in calculus. It is about application and optimization. We learned optimization the second unit, but now we are going to learn optimization in exponential and trigonometric functions. We are going to do this by solving examples. So I will do some examples for you. I will give you the homework, and you can send me your questions and I will answer them again, and then we're going to have our final assignment in this unit, probably by Tuesday. So what we are going to do today is I'm going to give you some examples. I will not going to write the examples because it will take the whole board. I will read it and then I will do it on the board. Okay, so example 1, it says the effectiveness of studying for an exam depends on how many hours a student studies. Some experiments show that if the effectiveness E is put on a scale of 1 to 10, then E, and they give you the equation, I will write it on the board in a second, where T is the number of hours spent studying for the examination. If a student has up to 30 hours for studying, how many hours are needed for maximum effectiveness? So in here we have a relationship between the effectiveness of studying and the time you spend studying. So this is the relationship between the effectiveness of studying and the time spent studying. This relationship, so time is the amount of hours, how many hours you put in studying, and this is how effective it is. You're studying from scale from 1 to 10, and they give us that the maximum hours of studying per week is 30 hours. So T is between 0 and 30. This is the domain of the function. I will give you a graphical meaning of what we are trying to do. Let's say this is the relationship, this is the time, and this is the effectiveness of studying. This curve, I don't know how it looks like, but let's say it looks somehow something like this. I don't know. And then it starts to go down somehow. So there is certain time in hours we're going to have the maximum effectiveness. This certain time is between 0 and 30 hours. We need to know what is that time. So when we have a maximum, the slope of the tangent will be 0. And the slope of the tangent means the derivative is 0. So we need to know at what time the slope of the tangent will be horizontal. The slope of the tangent will be horizontal, so the slope of the tangent will be 0. In other words, at what time the derivative will be 0. Okay? So simply we are going to find the derivative and we make it equal 0 and we solve for t. That's it. So the derivative of this is derivative of the second? Derivative of the second is e to the power of negative t over 20 times the derivative of the exponent here, negative t over 20 is the same thing as negative 1 over 20t. So the derivative of this will be negative 1 over 20. Okay, plus the second times the derivative of the first, which is 1. The derivative of t is 1. Okay, this is the derivative. We can factor out the common factors, so e prime of t will equal, this is common, so e 0.5 times e to the power of negative t over 20, open brackets, this will leave, from here is negative 1 over 20t plus 1. I hope I did it right. Seems fine. Now I am going to solve this when this is 0. We said before we need to find the derivative t that makes the derivative 0. So 0 equals 0.5 e to the power of negative t over 20 minus 1 half t plus 1. Alright, so now we have to, this is 20. We have two things multiplied together and the result is 0. So to find what makes this 0, we need to separate those. So either 0 equals 0.5 e to the power of negative t over 20 or negative 1 over 20t plus 1 equals 0. And we try to solve these two equations. In here, I told you many times that this is an exponential function. So I cannot find, there is no exponent that will make this 0. Alright? Even if you try to do it by log, or if you imagine how this looks like, it has an asymptote at the x-axis. So from here, there is no solution. If you try to take log both sides, it will not gonna work because ln 0 is undefined, it's error, so you cannot do it this way. So there is no solution from here. And from here, t will equal, we're gonna send the negative 1 to the other side and multiply by negative 20, so 20 hours. Okay, are we done? No. Remember when we did this, we said that the maximum could be where the derivative equals 0 and at the boundaries. So those are the boundaries. So we need to find e of 0 and e of 30 and e of 20 to see which one will give us the maximum effectiveness. I don't have a space, but I'm sure that all of you can do this. So e of 0, if you put 0 here, this will be 0. So it is 10 times 0.5, which is 5 in the scale. This is the scale from 1 to 10. If it is 30, this will be 30 times e to the power of negative 1.5. So it is 8.3. So the effectiveness here is 8.3. If you put 20, the effectiveness will be 8.7. So the maximum happened after 20 hours of studying. Probably after 20 hours you get tired, then there will be no effectiveness. The effectiveness starts to slow down. So this is an application question type. understand it. Okay, I want to do at least 2 more examples. Okay, so I will start this the second example now, but I will finish it in another video because the time limit. So let's do this one. Alright, I read it. A piece of pipe is being carried down a hallway that is 10 feet wide. At the end of the hallway there is a right triangle turn, and the hallway narrows down to 8 feet wide. What is the longest pipe that can carry it? It has to be horizontal around, so I cannot bend the pipe. It is flat pipe around the turn in the hallway. Okay, so I'll draw a picture. We have a hallway. It is the width here is 10, then the right angle, and it became narrow, 8. We are going to put a pipe and we need to find the longest pipe possible. Okay, in this hallway, in this with these circumstances. Okay, all right. In optimization question, if you remember what we used to do, the first thing is we draw a picture. The second thing, we need to determine what needs to be optimized, what we want to make it maximum or minimum. Here is the length of this pipe, so that's what we want to maximize. Then we try to find an equation for the length of this pipe that we want to maximize. This equation may have more than one variable. We must have only one variable, so we try to use information given to make all the variables only one. Then we try to find the derivative and find the maximum or the minimum. Okay, so I will continue on the next video. All right, see you soon.